Good morning students, welcome back to chemistry class. Today we are going to see the continuation of the last class. Okay, so last class we discussed about pure substance. Today we are going to discuss about the same chapter only. Today we are going to discuss about impure substance. So before going into impure substance, once we recap the previous class question. Okay, so what is pure substance? Standard itself I said pure substance means what? It is homogeneous and made up of same element or same compound. Okay, and various examples also already we have seen. Okay, so today we are going to see the next classification of matter, that is impure substance. Okay, so what is impure substance? First we can see the definition for what is impure substance. Okay, impure substance means it may be made up of one or two elements. It is made up of one or two elements, or it is made up of one or two compounds, or it may be made up of elements and compounds. So once again I am saying, what is impure substance? It is the substance that contain one or more elements or one or more compounds, or it is a combination of both elements and compounds. Then these substances are said to be what? Impure substances. Okay, it is either one or two elements or one or two compounds, or both elements and compounds. When they combine each other, we will get what? Impure substance. Okay, and when they combine at any proportions. Okay, these elements they combine at any proportion. There is no definite proportion for combining these elements or elements with the compounds. They will combine at any proportion. Hence, when these elements or compounds are mixing together, there will be no formation of any new compounds. Okay, there will be no formation of any new compounds. So, what is impure substance? It is a combination of one or more elements, or it is a combination of one or more compounds, or when we combine element and compound, they also forms what? Impure substance. And these compounds or these elements, they combine with each other at any proportion. There is no fixed proportion for combining these substances. Okay, it is physically combined at any ratio. And also, since they are combining in any ratio, there is no formation of any new compounds. Okay, when we hear this impure substance can be also called as mixtures. The impure substance can be also called as mixtures. Okay, so from the word mixture, what you remember? The snacks that you eat, isn't it? Mixture. What are the components that present in that mixture? Different kinds of components are there. Curry leaves, groundnuts, different components that together only called as what? Mixture. And all they are combined at what ratio? Any ratio physically, isn't it? By the humans. They will take some curry leaves, different type of groundnuts and make this mixture. Like that only, here also one or two elements they combine at any ratio. Like that, one or more compounds we can mix at any ratio. Like that, either compound as well as elements we can combine each other at any ratio. So there will be no proportion for combining. Hence there will be no new compounds are produced. Okay. Some examples we can see for understanding the impure substance clearly. See the first example, air. You know air is universally found, isn't it? Everywhere is filled with what? Air. Do you think air is a pure substance or impure substance? Air contains only one kind of element, or it contains only one kind of gas? No, isn't it? It's a mixture of various gases, hydrogen gas, oxygen gas, nitrogen gas. So many gases are filled to form what? Air. Since air is called as what? Impure substance. It's a mixture of various gases. It is a mixture of gas, water vapor, etc. It is a mixture of different gases, water vapor, etc. Hence, air can be called as what? Impure substance. Okay. The next example, blood. So, do you think blood is a pure or impure substance? It's a red in color. So, do you think it contains only one kind of elements? No. Okay. Blood contains so many components. What are they? RBC, WBC, platelets, platelets, plasma, etc. So, blood is also comprises of what? Different kinds of components. Hence, blood also comes under where? Impure substance. Okay. The next one, seawater. See, normally the distilled water, that we can call it as pure water because it contains only one kind of molecules, that is H2O. But seawater, it does not contain only H2O molecules. It also present what? Sodium chloride is present, so many dissolved gases is present, and many other substances also present in where? Sea water. So, sea water is not only made up of H2O, NaCl, dissolved ions, gases, etc. are present in sea water. Hence, sea water can be also called as what substance? Impure substance. Okay. Most of the components that we are using day to day our life, or most of the solutions that we are preparing in our home, it is made up of mixture. For example, lemonade. For example, what? Lemonade. So, lemonade means what? Normally lemon juice, isn't it? How we will prepare? We will take a cup of water and we will add some sugar or salt, or we will squeeze a lemon. Whether we are adding all in proper proportion to get a lemon juice? No. Physically we are preparing. So, approximately we are making what? Lemonade. So, this lemonade also comes under the impure substance because we are adding all the components at any proportion. Okay. So, lemonade also comes under where? Impure substance. Coffee that you are preparing also comes under where? Impure substance. Milk. What the milk, whether it is pure? We think it is made up of only one component because it is white in color. You cannot see any other components through our naked eye. But it is not that. It contains fats, proteins, etc. Okay. So, it is also made up of different components or different molecules. Hence, they are also called as what substance? Impure substance. The next one example is alloys. So, did we hear this word before? Alloy? Alloy means it is a combination of different metals. It is a combination of different metals, or it is a combination of metal with metal or metal with non-metal. So, when these elements are combined at any proportion, we will get to what? Alloys. Okay. So, these are the some of the examples for impure substance, students. Already I said impure substance means combination of various elements or compounds, or both elements and compounds. Okay. Air, it is a mixture of different gases, water vapor, etc. So, it contains two or more different substances. Hence, it is called as what substance? Impure substance. The next example is what? Blood. Blood contains so many components like RBC, WBC, platelets, etc. So, blood is also contains all. Blood also can be called as what? Impure substance. The other example, seawater, lemonade, and alloy. Alloy is the combination of different elements, or the elements with different elements means metals with metal or metal with non-metal. Both forms what? Alloys. Okay. We are mixing both the elements at any proportion. That is approximately we are mixing. For example, the example for alloy, brass, bronze. These both are called as the alloys of copper. Both are called as alloys of copper. That is, we are mixing copper with zinc and copper with tin to form brass and bronze at approximate composition. At approximate compositions, there is no need of mixing this at a fixed proportion. Just approximately, they are mixing what? Both copper and tin, or both copper and zinc to get brass and bronze. So, these are the examples for what? Impure substances. Do you understand? Okay. Now we can see the classification of impure substances. So already we studied the classification of pure substance. What are the two categories that comes under pure substance? Do you remember? That is elements and compounds. Like that here also, the impure substances are broadly classified into two categories. One is called as homogeneous mixture. One is called as homogeneous mixture. The next one is called as heterogeneous mixture. One is homogeneous mixture and heterogeneous. This classification. How they classified under homo and hetero means based on visibility. Based on visibility of components. Visibility of components. This classification is based on what? The visibility of components, isn't it? So, impure substance, that is again classified into two categories. What are they? Homogeneous mixture, and next one is what? Heterogeneous mixture, okay? And this classification is based on the visibility of components in the mixture. Visibility of components in the mixture. For example, blood. Already I said blood comes under where? Impure substance. And under these two categories, it comes under homogeneous. Why it is homogeneous? For example, we can say, take a test tube. In that, I am taking the blood. See, in this blood sample, when you see with your naked eye, can you see any RBC, WBC, platelets or plasma, anything on the blood component? No, you cannot see, isn't it? Whether this fluid contains any RBC, WBC, that can you see through our naked eye? No, we cannot see because it is completely dissolved and it was uniformly distributed. Okay. For example, milk. Take a cup of milk. Can you see the proteins, fats, everything with your naked eye which is present here? No, the components are completely dissolved and it was uniformly distributed from top to bottom. The components cannot be seen through naked eye because they are homogeneously or uniformly distributed from top to bottom. So only they are called as what? Homogeneous. Okay, that means they show single phase. And the components are uniformly distributed. And the components cannot be seen through our naked eye. Such mixtures are called as what? Homogeneous mixtures. Another one example we can see. So, homogeneous means what? For example, blood. All the components in the blood are uniformly distributed and they exist as a single phase. We cannot differentiate RBC separately, WBC separately, platelets separately, and we can call that as what substance? Homogeneous mixtures. And they are so in single phase and all the components are uniformly distributed. Another one example, salt water. Take a cup of water, add salt. Take a cup of water and add salt and stir it well. The salt particles that is uniformly distributed from top to bottom. Okay, the salt particles completely distributed from top to bottom. Okay, and every part of this solution has the taste of what? The salt, isn't it? So it is uniformly distributed from top to bottom. And whether you can see anywhere separately salt particles after dissolving salt? No, you cannot see because they show what phase? Single phase. So salt water comes under that mixture? Homogeneous mixture. They comes under homogeneous mixture. Okay. The next one is heterogeneous mixture. Next one is what mixture? Heterogeneous mixture. The best example, you can take sand and water. The best example, sand and water. Just see. Take a cup of water, add sand. What will happen to this sand? It will get settled down at the bottom of the water. And they show two phases. Above what will be there? Water. And here the solid particles will settle down. Okay. So it will show how many phases? Two phases. So it will show what phases? Two phases. That means it shows some boundary. Say we can see the boundary for this, isn't it? Up to this much water and here the solid particles are there. So this is the boundary. So it shows two phase or more than two phase or it shows boundaries. Okay. Such mixtures are called as what mixture? Heterogeneous mixture. Another one example you can take oil and water. Take a cup of water and add oil over it. Whether it will dissolve completely with this? Whether they will uniformly distributed from the top to bottom, we can see, isn't it? The oil that is spread over on the surface of the water particles, isn't it? But you cannot separate it. You cannot separate it. So oil and water, or the sand and water, etc. are the best example for what type of mixtures? Heterogeneous mixture. Otherwise, you can take milk. Milk alone means it comes under where? Homogeneous. Take some cereals and mix here. You can see the particles. The components can be seen through a naked eye and to show two phases. So milk with the cereals. With the cereals, it is called as what mixture? Heterogeneous mixture. It called as what mixture? Heterogeneous mixture. Once again, the impure substance are classified into two categories, homo and hetero, based on the visibility of the components. Okay. In homogeneous mixture, you cannot see the components through naked eye, and also it shows single phase, and all the components are uniformly distributed. Whereas in heterogeneous mixture, example sand and water, oil and water, kerosene and water, etc. They show boundaries, or they show two phases. They will show how many phases? Two phases. So they comes under what mixture? Heterogeneous mixtures. Okay. So the next we can see the difference between compounds and mixtures. The next we can see the difference between what? Compound and mixtures. Okay. So now we can see the difference between the mixture and compound through an example. Okay. See, iron that combines with the sulfur, iron that combines with the sulfur and produce iron sulfate. Students, we are going to differentiate mixture and compound. Through this example, better you will understand. Okay. So first, iron that combines with the sulfur chemically. That is, if we are heating these two, we will get a new compound called as what? Iron sulfate. A new compound called as iron sulfate. See, if you see the properties of iron, it can be attracted. It was attracted by what? Magnet. When we bring magnet towards it, what will happen? The iron will attract. We know, isn't it? The iron always attract towards the magnet. But the non-metal sulfur, it does not have this property. Okay. So this is grey in color, the sulfur yellow in color. When we mix these two, iron and sulfur, at a proper fixed proportion. At what proportion? Fixed proportion. And when they are combined chemically by heating, they produce a new compound called as what? Iron sulfate. New compound called as what? Iron sulfate. Now we bring the magnet towards it. Now, the iron will not be attracted towards the magnet. Their property is totally changed, and this iron sulfate does not show the properties of iron and sulfur now. Okay, now the iron sulfate is said to be what? Compound. Iron sulfate is said to be compound with new properties. At the same time, take a dish and take some sulfur approximately. Take some sulfur, not a definite proportion. Approximately you take some what? Sulfur. Now put some iron fillings over it. So they form a dirty yellow precipitate. They form one dirty yellow precipitate. Mix them. Okay. Iron fillings. Okay. Now we are not chemically treating. We are not heating. Now this is called as mixtures. Now there is no chemical reaction takes place. So we won't get any new compound because we have added at any proportion, and we does not combine them chemically, just by physically. We have combined what? Physically we have take some sulfur powder and we have added some iron fillings. Okay. Now you take the magnet towards it. What happened? All the iron fillings will be attracted towards the magnet, and sulfur powder can be separated, as well as iron magnets can be separated. So all the components that present in the mixture, they have their own properties. They have their own properties. Now this is said to be mixture, and this is said to be what? Compound. Okay. So the first point in contains one or more substance. It contains what? One or more substance. Their compound means it contains only a single kind of substance. It contains only single substance. For example, iron sulfate, H2O, etc. Okay, mixture means they may contain one or more substance mixed together physically. Mixed together what? Physically at any ratio. Physically at any ratio. This is what? It contains single substance that are combined and formed by chemically. They are formed by chemically at a fixed proportion. At a fixed proportion. Then they are called as what? Compound. Okay, ma? Mixture means one or more substances that are physically combined at any ratio. But here means it is made up of single substance and they are combined chemically at a fixed proportion. Okay. The next point, see the mixture, all the components present in mixture have its own properties. So normally the snacks I said, isn't it? If it doesn't eat curry leaf, with the help of hand picking, you remove the curry leaves. If it does not lick a type of nuts means you take it with the help of your hands, you remove the nuts. Okay. What are the things you doesn't like in that snacks? You just remove it. Isn't it? But this cannot be done in what? Compound. Okay. The components that present in the, see, iron sulfate. After forming iron sulfate, you cannot separate iron separately, sulfur separately by physical methods. Physical methods like what? What are the physical methods you know? At home we are using decantation, filtration, winnowing, sieving. So many techniques we are using for the separation of the particles. Am I right? Morning your mother used to what? Winnowing, isn't it? To remove the particles that are present in the rice, isn't it? So many techniques we are using at the home to separate the different components. So that is possible only in the mixture and it is not possible in the compound. So you cannot physically separate the components. We cannot physically separate it. The components present in the compound cannot be separated only by chemical reaction or only by chemical means we can separate the components that are present in the compound. Okay. But here the components to show its own properties and can be separated physical method. With the help of physical method, the components that present in the mixture can be separated. For that only I said some of the examples. What are the examples? Winnowing, filtration, decantation, fractional distillation, sublimation. So many physical methods are there to separate the components that present in the mixture. Because after adding one or more substance together also, these components, they have their own properties. They will retain their own properties. They will never change. Okay. And they never produce any new compound. So they have their own property. Salt has salty taste, water present water. Okay, with the help of crystallization or evaporation, we can separate water separately, salt separately. After that also we will get salt remain as salt, water remain as water. But here you see iron and sulfur after combining they produce a black color. Isn't it? This is grey color, this is yellow color. While mixing we will get a dirty yellow and if you undergo chemical reaction they produce black color with the new properties and it cannot be separated by the technique of distillation. Whatever I said, no, these techniques are not applicable to separate what? Iron and sulfur from iron sulfate. But where in mixture these are possible. So one more time I am saying difference between mixture and compound. They contain one or more substance and all these substances are combined physically at any ratio. Whereas compound, they produce a single substance or they contain single molecules and they all combined chemically at what proportion? A fixed proportion. Okay. And here the components retain their own property. Here the components, they never retain the properties. For example, iron attracted to a magnet, but here after forming a compound, Iron is not attracted towards the magnet because it does not show its properties. Entirely they will show the new properties. Okay, and they cannot be physically separated through physical techniques like distillation, fractional distillation, etc. Only with the help of chemical means we can separate the components of iron and sulfur from their iron sulfide. Okay, so do you understood what is the difference between this mixture and compound? So once again I am summarizing this. Today we have seen impure substance. It is a combination of different elements, compounds, or elements and compounds. So mostly that things that daily life we are using is what? Mixtures. Okay. Based on the components visibility, we are separating into homo and hetero. Homo means uniformly distributed. Hetero means not uniformly distributed. Homo we cannot see through naked eye. Hetero means we can see the components through naked eye. Next we have seen the difference between mixture and compound through one example, and these are the difference. So students, you please learn this question. In the book it is there. Okay, it is not the book back question, just you mark it. What is the difference between element and compound? Under this 4 or 5 points are there. Remember this. At the same time, Roman number 6, I hope at the book back, first one, there are some examples are given according to that to classify whether it is pure or impure. Okay, do as a homework. First question, I hope some examples are there. Do it. Next class we will see the answer for this question. Thank you.